is Lauren Bryant, and I am the Marketing Manager for Manufacturer Partnerships team at Partstown. And today I am joined with our partners from Accutemp, Daniel Cox, the Field Service Engineer, and Andy Sojak, the Help Desk Supervisor and Field Service Engineer. These experts are going to talk to us today about some valuable information related to the Accutemp Gas Evolution Steamer. They'll be covering the theory of operation for the steamer, as well as some key troubleshooting tips and best practices.
Good afternoon, everyone. I'm Daniel. I'm joined by my colleague, Andy. And today, as Lauren said, we are going to be talking about the gas evolution. Specifically, we are going to be talking about troubles with heating. So if a customer is calling you and they are saying that there is a problem with the call to heat, these are the steps that you will follow. To begin with, we'll start by talking about the AC circuit, which is one side of the call for heat, the DC circuit, and then finally what the ignition system does when it receives that call to heat. I would like to point out that most of what you're going to see today and hear today should be performed by a qualified technician. Obviously, we welcome all attendees because it's good to know this stuff, but I would not recommend testing this unit without first being qualified as a technician or an electrician. A quick little bit about the gas evolution steamer. It uses steam vector technology, which basically allows the steam to be convected, but without any moving parts. No pumps, nothing necessary like that. It doubles as a holding cabinet. We have it available in gas, propane, and there is an electric model, which we will cover on a later video. It's available connected or connectionless, which basically specifies whether it can fill itself with water or not. And it is one of the most energy efficient units on the market. For the basic troubleshooting, you will need for this unit a manometer, a multimeter that is capable of reading low voltage circuits, because this unit does have 24 volts AC and DC circuits. The multimeter will also need to be able to read DC microamps to test flame sense. The last thing you'll need is the Phillips screwdriver. Quick look at the components in this unit. A majority of the components are on the left-hand side of the steamer. You would remove the left-hand sheet metal panel, pull it aside, and that will give you access to the components. This image is available through the service manual. And before we continue, I'd like to draw your attention to the gas valve. When you are troubleshooting a gas steamer, I highly advise you to connect your manometer as the first thing you do. There is a port on the right-hand side of the gas valve. You connect your manometer in there using an 1/8" NPT. This will help you greatly in testing the call for heat, and I'll go into details on that as we go through the presentation. All right, the AC circuit. So this compromises the safety system for the unit. It controls the fill of water on an autofill unit, and we will go into greater detail on the fill system in a later video. It controls one side of the heat, and on a gas unit, it is a grounded circuit. If you test a wire to ground on this unit, you will get full voltage. So, first thing I'd like to talk about are the safety components. That comprises our single 3-amp slow blow fuse, an overfill read and float that is only available on the autofill, it is not needed on the manual, the AC coil control relay or control relay 1, and the thermal high limit switch. Now, as a quick update, we did recently update the thermal limit switch. That was phased in on April of this year, and it is not backwards compatible. If you'd like more information on that, we can answer any questions at the end of the slide. And then what you see in front of you right now is the AC control relay. Now, this relay is important for the circuit. It closes as soon as you plug this unit in. You'll notice that we have an arrow pointing manual fill only, and then we have the high limit switch highlighted in yellow. That is because with our schematics, they can be applied to both manual and autofill. Anything highlighted in yellow is autofill only. Manual fill wires will be identified by those arrows, so just good thing to remember when you're working on this equipment. The other thing I'd like to point out is that anything in this unit that has a violet wire running to it will have voltage as soon as you plug the unit in. I'm going to pass over to Andy right now. He's going to walk through a few brief troubleshooting for the safety system.
All right. Thank you, Dan. Thank you for joining us today. So we got the wiring diagram. So the purpose of this is kind of obviously sequence operation and also troubleshooting. So that being said, if a safety has been tripped, obviously the unit's not going to heat up, and then we need to figure out which safety has been tripped. The easiest way is look at there are lights under the control display, which will tell you either an overtemp or a high water condition. And in the wiring diagram, I've actually highlighted the wiring in red. So as Dan showed previously, we have our high water switch. Now the high water switch is being controlled by a float ball, which is located inside the cooking chamber. And inside that float ball, there's a magnet. So the switch is a magnetic reed switch. So for whatever reason, if that switch was to open, whether it actually has a high water condition or there's a problem with the switch itself or a problem with the float ball, this actually will de-energize the AC relay. And then once the AC relay de-energizes, it's going to go ahead and illuminate your high water light at the same time sounding the alarm. So the diagnostic side of it is if the high water switch is open, once again, we'll have to figure out the float ball, is it the switch or possibly the AC relay. Now, as Dan stated, as soon as you plug the unit in, this AC relay will energize. Now, so troubleshooting-wise is first thing we'll go to, if the relay is not energizing, do we actually have 24 volts AC going to the relay? Now, if we have 24 volts going to the AC relay, that'll tell me my switch is good and also my float. So at that point, if there's voltage going to the part, then it appears as we have a defective relay. Now, in the field, for me, it's always confirm, confirm, confirm. So I'll actually instruct the technician is to take the reed switch offline and plug the violet wire directly into the coil. Now, remember, the violet wire is hot as soon as you plug it in. So if we bypass the switch and we plug it in and my relay is still not energizing, then that's confirmation for me that, yes, I have a defective relay. That point is we'll give you a part number. You go ahead and order the part through Parts Town and go ahead and replace the part, and the unit should be up and running. Now, on the overtemp, once again, safety overtemp, the alarm will sound, and again, the overtemp light will illuminate. So we've got the light, and here's our switch as far as in the diagram as a whole. Now, as you can see, the switch itself is in line with power actually going to the main control board. So with the high water and the overtemp, you will not see a display. It will just be in an overtemp condition. Now, with the high water, same with the high water overtemp, is that these alarms will with the unit plugged in. And obviously, it's not turned on. So kind of going back to the high water, one really big safety factor is, this is maybe towards customers, even the tech if he arrives, is if it's a high water condition, you would unplug the unit, open the drain. Because if the alarm's going off due to an overfill, the last thing you want to do is open that door, and then there's a small chance of hot water and leaving the steamer and possibly causing, some harm. And same with the high water. So as far as testing the high limit switch, that's easily bypassed. All you got to do is basically take the switch out of circuit and jump across. Now, once again, this is for testing purposes only. we never leave a high limit or any safety bypassed. So if you would take to bypass that switch, using a jumper or just reconnecting the wires, and if everything turns on, at that point we know we have a bad switch. Now, with the high limit itself, if it's going to a high limit condition, there's a chance it might be the switch, but usually it's going to be the switch if it happens as soon as you plug the unit in. Now, if the high limit alarm is sounding during operation, it could be another issue, and possibly not the switch. Now I'm going to turn over to Dan.
Thanks, Andy. So we're going to move on and talk about the actual call for heat, specifically to start with on the AC side of the circuit. So what you're looking at here is a close-up of our digital controller. You can see the violet wire that feeds operational power to the controller right here. So this has power, operational power, as soon as the unit is plugged in. When you push the on-off button on the front of the unit, this contact closes. We have voltage from our AC relay here. It will then flow through the relay and out of the brown. This signal is continuous. As soon as the unit is powered on, that is there. There is no break to it. The control board does not control that signal based on the temperature of the unit. It is a continuous output. A few quick things to recognize a problem with the control board without actually testing anything. Obviously, pushing the on-off button, the unit does not power on, and you have no alarm systems, no alarms going off whatsoever. That could be an issue with the board. We're going to want to test the power coming in. If the LED display on the front of the board the customer can see is missing characters, again, it is a sign that the board should be replaced. Finally, if you're starting your test with the unit empty of water, as soon as you power it on, a low water light should illuminate, and that's constant across the board, autofill or manual fill. If your low water light does not illuminate when the unit powers on, it is a sign that there could be a problem with the control board, so that's where you'd start your troubleshooting. Just want to draw your attention to the water level sensors. Now, these are inside the cooking chamber on the left-hand wall towards the front. These sensors must be cleaned daily. If they are not, they can cause problems with both filling on an autofill unit and heating on both manual and autofill. These sensors engage to a water board. The water board is, again, connected to supply power. When the unit is plugged in, it receives power. You can see this as a good visual ID with a small LED. It will flash when the unit has power. A single-second flash is telling you the water board is not detecting water through the sensors. A 3-second flash is telling you that the water does detect, the water board does detect water, and it should be accepting the call to heat. Now, how does it do that? This is a close-up of our water board. Here, you can see the control circuit. There's our incoming power, and here are our 2 water sensors. The control board is mainly looking for a signal through our low water sensor to ground. When it receives that signal, it will close this relay right here. We have the dark brown power, which is flowing from our control board. When the relay closes, it is supplied to this red wire. The high limit sensor is mainly used for our autofill units. When water makes contact, it starts a 30-second countdown. When that countdown expires, the water will stop entering the unit. So where does that power go once it's hit the red wire? The first stop, as we would call it, is here on contact 5 of control relay 2. And this voltage doesn't go anywhere at this point. It is just sitting and waiting here, and it relies on the DC circuit to allow it to continue. The next spot is the pilot valve, which is the left-hand valve here. Now, this is one of the reasons that I had you connect your manometer before doing any other troubleshooting. When your AC circuit is satisfied, you will register static pressure on your manometer. It's a really easy way to test if one side of the heat circuit is working. And just as a side note, gas is not being supplied to the burner when this pilot valve is open. It is just sitting and waiting for our second valve, which is the main valve here, to open. Finally, the red wire terminates at our ignition module. It is only supplying 24-volt operational power to the module. The LED indicator on the module, which is located right here, will flash briefly when that AC power is supplied. So this is another good visual ID. Fill the unit with water, power it on. There is a brief flash on the ignition module that also tells you, hey, my AC circuit is satisfied. But I will say it is a quick flash, so you should be watching for it. I'm going to quickly pass over to Andy. He's going to walk you through the actual physical troubleshooting of the AC circuit.
Thank you, Dan. All right, so as Dan mentioned, we have a manometer hooked on, and once again, we're looking at a steamer that's not heating. So with the left panel off, before we do anything, what we're going to do is have you turn it on. Now, with the manometer attached to the dual gas valve, the dual solenoid valve, once you hit on, if you see a red light on the module and if you see static pressure, we are moving on, meaning that the AC circuit is running to spec. And at that point, we'll actually focus our attention to the DC circuit. But for educated purposes, what we're going to do is going to say that we don't see the red light, we don't have any static pressure. So we have a break in the AC circuit, so now we've got to figure out where that break in the circuit is. So once the unit's turned on, obviously anything we see with violet and yellow, that's basically telling me as soon as I got power, I have power going to my component. Now, before we actually turn it on, we have to double check to make sure that we have power coming off the AC relay. Once again, the AC relay is energized as soon as you plug it in. So we follow power, and then once the unit's turned on, that power will go from the AC relay up to the water board. So once again, we'll have to test the board, the control board, to see if we have output. Now, this is an output circuit, so at this point, we'll actually disconnect. Now, this is highlighted yellow, but the actual wire is brown, so we'll actually pull that brown wire off the board. Now, this is an output, so we'll actually be checking the pin. Now, as Dan mentioned, this is a grounded circuit, so we actually test the pin using our meter, AC volts, we'll test the pin to ground. Now, if we have 24 volts AC, the control port is good. If there is no 24 volts output, then we have a bad control board. At that point we'll give you a part number, the part's ordered, the part's replaced, and then the steamer, once again, will be operational. So for, let's say, okay, we checked, we do have 24 volts AC coming from the control board, so we have to kind of keep going down the line. So since we do have 24 volts AC coming from the pin of J74, so now we've got to check the same, make sure that's the input. Now we got to test to see if we have an AC output from the water board. Now, as Dan mentioned, is once the lower sensor, water sensor sees water, it's going to go ahead and close this relay. Once this relay is closed, power will be transferred from the control board via the water board to the red wire, which will hit, as Dan mentioned, will hit our DC relay, hit our module, and also hit our pilot valve. So at this point, what we'll do is remove the red wire off the water board, and once again, this is an output, so we're going to be testing the pin to ground. At this point, if we have 24 volts AC, the water board is okay. If we do not have 24 volts AC coming from the open pin to ground, then we have a defective water board, meaning that the internal relay is not closing, it's not energizing. So power is just sitting there waiting, and it's really doing nothing. But once again, we do actually have 24 volts AC coming from that pin. So if we have 24 volts AC, but we have static pressure because we know we have a manometer on, but we don't have a light in the module. Now, at this point, is ignition hasn't been triggered. So we're kind of keeping this guy out so we can test it here. But if we have power at the pin, and as long as there's no break in the wire, we're going to have power here, so I'd normally leave that alone. I know I have static pressure, so I'm not going to touch that. But once again, I do have an AC input basically energizing the module. In this situation, that if the light doesn't come on, no ignition, and I have pressure, I have a defective module. Or let's say we don't have static pressure, but I have power, I have a defective pilot valve. All right, now I'm going to go ahead and turn over back to Dan.
Thank you, Andy. So we're going to talk about the DC circuit side of the heating. A quick mention on the DC circuit. Like I said, it controls heat. This circuit is also responsible for controlling the temperature of the unit. So let's get into it. Back to the control board. When the control board is powered on, it rectifies a DC signal, 24 volts. The output is here on J71. The return or ground is here on J72. This means this is not a grounded circuit. You cannot test this circuit to ground. It must be done wire to wire within the circuit itself. I'll draw your attention to the fact that the controller does have an RTD. The controller, in cook mode, the controller outputs a constant DC signal. It does not modulate the signal based on the input of that RTD. The only time it will modulate that signal is when the unit is set in hold mode. But in cook mode, general use, it is a constant output. The DC voltage first meets the door switch. It's a simple magnetic proximity switch. When the door is closed, the switch should be closed. And then we come to the pressure switch. This is the component responsible for controlling temperature in the unit. It is a normally closed switch. When we achieve steam pressure of 0.5 inches water column, it opens and it breaks the circuit and stops the unit from heating. So if your unit is not heating, you've confirmed the AC side is good. This is one of those that could be responsible. The timer relay. It's a simple relay. It receives voltage, delays conductivity by 5 seconds, closes, voltage continues. It's mainly there to prevent both gas valves opening at the same time. Finally, we'll come to a familiar component, the DC relay. The coil of this is energized by DC voltage. When the contacts close, the AC voltage that was waiting at 5 from our water board can now pass through onto a red and white wire, and that carries it on to the ignition module. I'm going to briefly pass back over to Andy. He's going to walk you through how we would test this circuit.
All right, so once again, we're still at a steamer. It's not heating. Now, we're going to focus on the DC circuit because when we first turned it on, we have static pressure on a manometer, and also we got a brief flash from the ignition module. At this point, I know that circuit is good. I'm not going to worry about it. So now I'm going to focus on the DC circuit. So as Dan stated, voltage is rectified into 24 volts DC. We have our ground, which is our orange wire highlighted, and the wire is actually orange, going to the negative on the DC relay. But once again, everything starts at the control board. So as DC voltage leaves, first stop is going to be the door switch. So I'm just to kind of back up. Sorry, let's back up a little bit. So kind of going back, let's make sure that we actually have a DC output from the control board. At this point, I'll ask you to remove the black wire, black or red wire. That wire color has been changed, but it's a thin wire that's right next to the orange. And I'll have it remove both wires. And these two, you'll actually have to test across 2 pins. So pull the wires off. Do we have 24 volts DC output from the control board? No output. If we have no output, then we definitely have a defective control board. If we have the DC voltage output, then we'll have to go to the next component. And once again, looking for the break in the circuit. So first stop is going to be the door switch. Now, we can test the door switch or bypass the door switch. Let's say, for example, we bypass the door switch and the system starts to heat up. Now, that doesn't necessarily mean it's a defective door switch. This door switch or door handles, as far as the magnetic field, are pretty much made with this door switch. So we've had situations where people have purchased non-OEM door handles and the magnetic field wasn't strong enough to actually close that switch. So once again, if you need a door handle, OEM, that's when you want to order that part from Parts Town. But for testing purposes, we're going to say a switch is good, so we jumped it, and still we have no call for heat. So our next stop is going to be our pressure switch. As Dan mentioned, it's a normally closed switch. The switch will open once the chamber pressure is at a half-inch or water column pressure. Easy enough test, we can test across the switch, or we can just go ahead and jump the switch. So if we test across and show the switch is closed, or we jump it, and we still have no call for heat, then we'll have to actually look at the time, the delay timer. Once again, it's got 2 wires going to it. The common will get power after 5 seconds. That will close, and once again provide power to your DC relay. So easy enough. We can test across, or for me, hey, just go ahead and jump it. Let's see if it works, and then we'll go ahead and bypass that switch and see if that relay pulls in and see if it starts calling for heat. So once again, we jumped it, and nope, still no call for heat. At this point is we know we have power coming across. We've tested all of our components, and so the next step would be is actually removing the blue and orange wire, or as depicted, moving the 2 wires off the DC relay and see if we have 24 volts across the 2 wires. Now, if we have the 24 volts and the relay is not energizing, then we have a defective relay. Now, let's say the relay is energizing, but we still have no power transfer from the red to red and white. That means we have a defective contact within the relay. But either way, it's a defective relay. Right, now I'm going to pass over back to Dan.
Thank you, Andy. And so we come to the ignition circuit. We've had our call for heat. It's reached the module. What does the module do with that signal? Well, if we know those circuits are good, the first thing that we're going to look for is the LED light on the module, which is right here. If you know both sides of your circuit are good and you have a solid red LED on the module, that is showing a control fault within the module itself. Our advice at that point would be to restart, as in power the unit off and back on. Does the control fault resume? If it does, you have a defective module. If we look quickly at the wiring schematic, you'll see that we've got our double red here, which is where our AC supply voltage comes from the water board. And we have the end of the red and white wire, which comes from the DC relay contact 3 right here. So what does the module do at this point? Well, the first thing it's going to do is it's going to send line voltage to our blower. The blower is going to engage. The airflow creates a vacuum which closes this fan pressure switch, which is located on the right-hand side of the ignition module. The module is looking for a completed signal through that switch. If it does not see the signal, it will pause the lock. It will go to lockout. It will stop ignition, and you will see a single flash code on the module LED. This signifies airflow fault. Either the fan switch is not closing, or there's some other problem going on there. If the module is satisfied that there is an air current and the blower pressure switch has closed, at this point, it sends voltage to the right-hand valve. Now, again, if you've got your manometer hooked up already, you will see that static pressure that we mentioned earlier drop down to dynamic pressure. This is a really good way to also test, are both sides of my circuit working? If DC and AC are happy, you'll see first static, and then you'll see dynamic. It's a really easy visual indication to check if this unit's operation. Once the main valve has voltage, gas can now reach our burner. At the same time, the ignition module is going to send 180 volts through this high voltage cable right here to our igniter and attempt ignition. This is an inside look at the ignition probes, which is right here, and the grounding rod, which is here. We're looking for a spark around here. Obviously, we've got gas coming through our burner. We get ignition. At this point, our flame sensor is going to react with that flame and produce a DC microamp signal. The minimum signal needed to keep the unit lit is 0.3 DC microamps. Typical strength of the signal is around 2.5. If you're running the unit from a cold start, it may get up towards 4 or 6 even. But once the unit's at temperature and it's cycling, 2.5 is the average. The ignition module is looking for this signal. If it does not see the signal, it will enter lockout and give you a 3-flash code on our LED. I'd also like to mention that from August 2018, we did make a modification to this module. It will try to ignite 3 times. So it will start the blower, it will attempt ignition, it will continue the blower running for 30 seconds after a failed ignition before trying again. So the blower will continuously run throughout this try. If it is unsuccessful, again, 3 flashes. And that module is backwards compatible. So if you are replacing an ignition module on a unit older than August of 2018, you will use the new 3-Triumph module, and that is available from Partstown. I'm going to pass it back to Andy, and he's going to walk you through testing the ignition circuit.
All right, thank you, Dan. All right, so again, pretty much good detail as far as how the ignition circuit works, but we're going to come look at some troubleshooting. So once again, we went through our AC, we went through the AC system. We do have our flash. We do have static pressure. I know my DC relay is pulling in at this point. So we're still not calling for heat. Once again, the module will tell you a lot. Obviously, if you've got ignition lockout. Now, ignition lockout could be due to a poor flame sense signal, or possibly we have a defective main valve. So it's kind of follow the power. So as Dan said, the first thing it's going to do is going to energize the blower. So once the blower is energized, and we know DC relay is pulled in, then what the module is looking for is make sure that blower switch, which is normally open, is pulled in. So once it sees 2 points, at that point it's going to start the ignition process. So from there, the module will do is go ahead and actually send power to your main valve. And once, obviously, you get power to the main valve, at the same time, you will have power at your igniter, which will light the gas. Once again, if it goes into a lockout, that could be either the flame sensor or the ignition module itself. Easy way to test is shown on the next slide, is we do have 2 points on the module that you can actually hook up your meter. Remember, meter has to be set to DC microamps, so you've got your black to red. And from there, you can read your amperage. So some equipment, you actually have to put your meter in series because amps can only be checked in series. Not with this module. At this point, if there's no existing flame sense, more than likely it's going to be the module, because even if the flame sensor is going bad, unless it's completely broken, you should get something. But if there's nothing, 0, you more than likely have a bad module. But if we're not sure, we might even just say just take both parts with you just in case. And obviously starting with the module first. So once again, power comes in, hit your blower. From there, we'll start the ignition sequence, open your main valve, at the same time sending power to your igniter. All right, so basically what we looked at, so in this case, obviously everything, we tested everything looked good. That's the thing I want to talk to you about. You know, this pretty much covers I'd say 98% of the issue we see in the field, and we still got that little 2% that, you know, things that don't make sense. And when we come across that 2%, when we tested everything, and based on what we're seeing, everything should work, and you see everything kind of comes together from, we have our safety, we have our AC voltage, then we have our DC circuit, and then we have our ignition circuit. At that point, that's what I'd actually recommend, or, you know, if you're even not familiar, just call our help desk. Now, we are open 7 days a week, 7 a.m. to 7 p.m. Eastern time. So, yes, we do have a technician on call Saturday and Sunday. And or leave a message. But our technicians are fully trained, and our mission is to stay on the phone for as long as it takes until we're satisfied and you're satisfied that we've actually found the problem. We want you guys to call us, even if it's a simple question, even if you want to just make sure, because for me the worst thing is kind of getting the wrong part in the hand. Now you go to the customer, put the wrong part in, and now, okay, it's not the right part, the unit's still down, then you're going to call tech support, but still the customers are going to be down more than what they should. Just to verify, go ahead and call us. And like I said, we work for you guys. So now I'm going to turn over back to Lauren.
Thanks, Andy, and thank you guys for that valuable information. There are a few minutes left for questions, and we actually have a couple in queue. The first one is about the water board. What happens if the light on the water board does not flash during the call for heat?
If the light on the water board does not flash, now this isn't directly related to the call for heat. That light is wired to our control of the water board, which is receiving operational voltage. If that light is not flashing when you plug that unit in and you have no alarms on the front of the unit, that's overtemp, high water, low water, nothing at all, we are going to suspect the water board. Now, you would check, of course, voltage at J3 violet to ground to make sure that the voltage is being supplied to the control side of the water board. But as it's tied to the control, if voltage is there, that is a defect on the water board. It may not affect actual operation. It may just be burnt out. But for future troubleshooting, it would be recommended to replace that board.
Thank you, Daniel. The next question we have in queue is, what do you do if there is a lockout when testing the ignition module?
Could you repeat that, please, Lauren?
What do you do if there is a lockout when testing the ignition module?
Well, if there's a lockout, so let's kind of go back to that screen there. Kind of give me a second here. All right, so if there's a lockout, so that could be due to a couple of things. It could be for some reason your main valve's not opening. Or let's say even the valve, let's say your pilot's not opening, and so you have defective pilot. So if there's no gas getting to the burner, it's going to go into a lockout. So that's one reason. It could be either due to either your pilot or defective pilot or main valve, or the gas pressures could be low. For example, especially on an intermittent situation where the supply pressure is too low to support the equipment, or too much gas equipment on the line, so either no gas or not enough gas. We are not getting a spark at the igniter, or we're getting a weak flame sense. That could be due, once again, to no gas, low gas, or possibly a defective flame sensor. Or it might be going back to the module where the internal circuit that reads that flame sense is not picking up the DC microamps.
And if I could just add something on to that, when you are testing this unit and the module goes into lockout, an easy way to restart the circuit is to open the door to the unit and close it. That will open your door switch. The door switch then closes. The DC relay closes, and at that point we have a new call for heat supplied to the ignition module. So while you're testing this equipment, opening and closing the door is the fastest way to reset the ignition.
Awesome. Thanks, guys. As both Andy and Daniel mentioned, remember you can always contact Accutemp Service and Support directly if you have additional questions. As also was previously mentioned, Partstown is proud to be a master distributor for Accutemp. Which means we are your one-stop shop for the most in-stock parts ready to ship same day. That includes parts that you may need for your gas evolution steamer. Before we end, I wanted to also invite all of the attendees and participants of the webinar to check out TechTown, which is the only online forum where food service technicians can engage with each other, ask for help, share expertise about equipment and tools, and learn tricks of the trade. Visit techtownforum.com to get engaged. We've also invited our manufacturer partners like Andy and Daniel to engage on the tools so you'll get firsthand knowledge straight from the experts. Thank you for attending today's webinar. Make sure to complete this short survey that's headed your way and let us know what you think. More information on the Accutemp equipment and the processes described today are headed your way, including the webinar replay and more troubleshooting tips from the experts along with their contact information. We'd love to offer more events like this in the future, so your feedback will help inform us of those topics, format, and timing that best meets your needs. Thank you again to our presenters from Accutemp and for your time. Everyone have a great afternoon and happy holidays.